Okay, so we're going to look briefly at sequences and then touch on series. Most of this is probably going to be revision from GCSE. So what is a sequence? So a sequence is simply a sequence, a list, if you like, of numbers. So the two types of sequence we're going to look at look like this. And if you were to just look at these, I'm sure you can work out what the rule is to continue these sequences on. So you've probably already said to yourself, well, this is easy. The rule to get from one number to the next is simply I'm going to add 2. Okay, so this is the rule for sequence number 1. We're just adding 2. So the second one is slightly different in that we're not adding this time. What are we doing? We're multiplying by 2. Okay, so here we're multiplying by 2. And these are the two main sorts of sequences that you need to know about. There are some others, which I'll just mention here, and I'm sure you're familiar with this sequence. So if you just think to yourself, wait, what are the next two numbers? I'm sure you'll come up with 13 and 21. So why is that? This hasn't got the same sort of rule here. You can't define one number. You can't look at one term and then just say what the next term is. Here you have to know the previous two terms, and the rule is that we add the previous two terms to get the next term. So we've got 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3, and so on. So this is a different type of series where we're describing it as a recursion relationship. So as long as you know any two adjacent numbers in the sequence, then you can carry on the sequence indefinitely. So this particular one, and I'm going to embarrass myself, I should have looked up how to spell it. I think that's right. So this is the standard Fibonacci sequence that crops up an awful lot in nature. So we'll probably come back and look at this some other time. But for now, just want to concentrate on these two types of sequence. Now they've got different names. So this one, where the difference between the numbers is an addition, is called an arithmetic sequence. And this one, where we've got a common multiplying factor between the terms, is called a geometric one. Okay, so that's the basics of what sequences are, and as I say, we'll come back to Fibonacci another time. So let's just move on and let's look now just at arithmetic sequences. What I want to think about, so let's have another one of these sequences. Let's start with 3 and we'll do this. Okay, my brain has just gone. I was just doing a Fibonacci one, so totally ignore me. So the pattern here, you can see we're adding each time 4. Okay, so we could carry this on indefinitely. So the two things we need to think about are, what do we need to know to define this series so that you could carry it on? So what do we need to know? So they're sort of like our starting values, if you like. What do we need to know to define the sequence? Okay, and usually we also want to be able to describe, say, what the 100th term over here is, without having to go through the whole calculation. We don't want to have to calculate all of these to find, say, the 100th or indeed the 1000th or the millionth term. We want to come up with an expression for calculating the nth term. So these are the things we're going to look at. Okay, so an expression for the nth term. So what defines the whole sequence? So if we think about it, we definitely need to know what we're adding. Okay, so we need to know the the addition, or what is often called is the difference. Okay, and if you think of it as the difference between terms, then it makes sense that usually in the formulae we call that d. Okay, so that's the difference between terms. So we've got the difference, but there's obviously something else we need to know. We need to know the first value. Okay, so if we know the first value, we can continue this sequence on indefinitely. We could know any value in here, as long as we know what number value it is. Okay, so I could start and tell you, well, 15 is in the sequence, and then I could happily carry on the sequence into the future, and I could go backwards, because instead of just adding the difference, we can start to subtract the difference. But if we're going to talk about, say, the 100th term, then we need to know where we're counting from, so what is called the first term. So that's ideally what we need to know. So we need to know the difference and the first term, or a way of calculating the first term. Okay, so if I gave you the third one, you'd be able to go back, work out the second, then the third one, you'd be able to calculate the third, and then the second, and then the first, and get back to the first term. Okay, so we want to know what the first term is, and it's easy to remember. We're going to use A for that, just like the first letter in the alphabet. Okay, so first term is A, the difference is D. So that's what we need to know. So now let's think about how we're going to calculate the nth term. So we've got our first term A. So our second term, if we're going to express this in a generic way, that would be A plus D. The third term is A plus 2D, and so on. Okay, so I want you to think to yourself, this is the first, this is the second, this is the third, and so on. So what's an expression going to be for the nth term? So if we think about it, we're adding D on each time, and by the time we get to the nth term, how many lots of D will we have added? It's tempting to say it's n lots of D, but it's not, because the second term we've only added one lot of D. So here we've got A, and then not n, but n minus 1 lots of D. Okay, and that's the formula for the nth term of an arithmetic sequence. Usually with sequences, it's usually common practice to use un to represent the nth term. Okay, so that's often what you'll see. So if we just write this down, we've got un equals A plus n minus 1D. Now I don't think you need to learn this formula, because if you just think about what the sequence is, it becomes fairly obvious what that formula is. So you should be able to just create this every time you need it. So remembering here we've got the difference is D and the first term is A. So that gives us this. Now in GCSE you may have come across a method which I think is a tiny bit crazy, but there you go, where they talk about, you work out the difference and then you go back and you calculate the 0th term. Okay, and then they say un equals the 0th term, okay, 0th, however one spells that, the 0th term plus n times D, which turns out to be exactly the same with this, because the 0th term is A, so the first term minus D. Okay, so that's our 0th term plus ND. So if you just collect your D terms, you can see that this is the same as A plus N minus 1D. So I don't like this, but I've seen it explained like this in a couple of GCSE books. So let's just look at one simple example. Right, so let's look at an example from the textbook you've got. Let's just work through this first example, which is, it gives us a sequence here, un equals 55 minus 2n. Okay, and what it asks us to do to start with is write down the first 5 terms of the sequence. So let's write down the first term. So the first term, n is going to be 1, okay? It's tempting to put n equals 0, but the first term is n equals 1. So we've got 55 minus 2 is 53. The second term, let's put n equals 2 in here. So we've got 51, and so on. Okay, so we can just see now that we've got our starting point and we're going 2 down each time. So then it says, what's the 99th term? Okay, it wants us to find the 99th term. So what do? We simply have to put n equals 99 in here. So un, or u99, so the 99th term is 55 minus 2 times 99. Okay, so if you work that out, we get minus 100, whoa, missed my one, minus 143. So that's all it's asking us to do. And then it asks us to problem solve a bit, and it says, what's the first term that's negative? So what's it asking us here? Well, all we've got to do is we've got to say, so we want the first term to be negative. Well, that's going to be when 55 minus 2n is less than 0. So we want the first value that this occurs for. So if we just solve this inequality, we've got minus 2n is less than 55, minus 55. Okay, now if we want to flip this, whenever we multiply, I would suggest here we change the sign. So we're going to multiply by minus 1, which is what we mean by flipping the sign. You have to remember that you change the inequality. So if you're not convinced about that, go back and convince yourself about that. So we're going to get 2n bigger than 55. So n bigger than 55 divided by 2, which is 27.5. So we've got n bigger than 27.5, but n is a whole number. It's got to be one of the natural numbers, so we must have the smallest value of n is n equals 28. So the first term that's less than 0 is the 28th term. Okay, so you'll be able to go ahead and just do some questions with arithmetic sequences. Excuse me. So now let's just take a look at the other one. We've got geometric, so let's do the same thing again. Okay, so geometric sequences we've said are defined by the way to get from one element of the sequence to the next one is we're going to multiply by a common factor. So let's just have a little peek at how we're going to define what we need to define one of these sequences, and let's determine a formula for the nth term. So we can start off with the one that I had originally, which we've got a common term, or we're multiplying by 2. We can have sequences where this term is less than 1. So we could have a sequence that's, well, we could sort of turn this on its head and we could go 32. Not quite turn it on its head, I'm going to do something slightly different too. So what am I doing now? Well, I'm dividing by 4, okay? But a geometric sequence we're defining as multiplying by a common factor. So dividing by 4 is the same as multiplying by a quarter, okay? So we're going to multiply by a quarter again to get 2, and if we multiply by a quarter again, then we're going to get 2 over 4 equals a half, and so on. And so you can see in this term, these numbers, the elements of the sequence, are going to get smaller and smaller and smaller and smaller, but they're never going to get below 0. They're going to get really close, but they're not going to get to 0. So in this case we're multiplying by a half. Now you can get weird sequences where you actually have a negative number as your factor. and in which case we'd get something like, so we suppose we start by 3 and let's multiply by negative 2. We'll go 3 minus 6 multiplied by negative 2 again, so negative times a negative is a positive, so we're going to get 12 times by minus 2 minus 24. So you can see that this pattern's just going to keep going, and we're going to have alternate positive and negative numbers, and this is just an alternating sequence. Okay, so we can call that an alternating sequence. So something to mention here is, I told you that in this case we're going to get closer and closer to 0, so we could say that the limit of the sequence, the limit is 0, right? Because it's going to approach there, but it's never going to get there. And another term we could introduce here is we could say it converges, right? It converges to a limit. Okay? So this is going to be true. We're going to converge to a limit. If you think about it, when are we going to converge? Well, the thing we're multiplying by is going to have to be a fraction, so that the actual number gets smaller and smaller. But it could be positive or negative. If this had been multiplied by minus a quarter, we'd have just had these alternating, like in the alternating sequence, but they would still have got closer and closer to 0. It's just they would have been approaching it from both directions as we go. So if we've got a graph, and this is, we're plotting UN on here, then they're going to be going something like this, aren't they? It's going to go from there, here, here. So we're going to gradually converge from both directions towards 0, but we're still going to, 0 will still be our limit. So they're the terms you need to be aware of, and I'm sure those are all pretty familiar to you. So let's see, what do we need to know? So thinking again, what do we need to know to define these sequences? Well, again, it's the same as last time. We need to know the first term. If we know the first term, and we're going to call that A again, and we know the common factor that we're multiplying by, or ratio. Okay, so it's probably more normal to call it the ratio between our numbers, and then we're going to call the ratio R. So remember, in an arithmetic we called it D for the difference. In here we're going to call it the ratio R. So let's think again. For a generic sequence, our first term is A, our second term is A times R, third term is A times R squared, and so on. So what's the nth term? Okay, so very, very similar to what we did for an arithmetic sequence. We say here this was the first, and this was the second, and this was the third. And I'm sure you can see we're just multiplying by R each time, so by the time we get to the nth term we will have multiplied A by R how many times? It's going to be n minus 1 time. So here our formula that we need to know is that UN equals A times R to the 1 minus n. And if you're not convinced about how you write your letters, sometimes you might find it clearer to actually put that in brackets. So there you go. So that's pretty much all there is to that. So let's just pop that in a box. That's the thing that you need to know here. UN equals A times R to the 1 minus n, where you've got these two terms. So let's just do one worked example here. So I'm interested in, okay, so let's look at something that's let's look at an example in your book that's a bit more complicated than a standard one, because I think they're very easy for you. So let's have a look. What it tells you is that the first 3 terms of a sequence are these. So we've got 3x and x plus 6. Okay, and it says they're the first 3 terms of a geometric sequence, and it tells you all the terms are positive. Okay, so we already know by this, if all the terms are positive, then we know that r must be greater than 0. Okay, so that's what that bit tells us. And what it wants us to know is it wants to know tell us what are all possible values of x. Okay, so let's think about how we're going to do this. So a way to approach this is to say, because this sort of doesn't look like a geometric sequence. Okay, so what is a geometric sequence? So if it were a geometric sequence, then we'd be multiplying by r each time. Okay, and we'd multiply by r again. So let's think, we've got u1, u2, u3, and we've got, yeah, let's just leave that, and then we're carrying on. So what we know, if you think about it, we know that u2 divided by u1 must be the same as u3 divided by u2, which equals r. Okay, so let's plug what we've got in here. So u2, this gives us therefore x, which is u2 over 3, equals, we've got x plus 6 over u2, which is x. And so we can just solve this, and then we should be able to see what values of x we've got. Okay, so we want to know what values of x can satisfy this, right? So values of x. So I suggest what you do, we just go ahead and solve this. So let's do it together. So the first thing I always see when you see this is having your variable on the bottom is a pain. So let's first of all get rid of that. So let's multiply by x. So on this side we're now going to have x squared over 3 equals x plus 6. Fractions are a pain, so let's multiply by 3 to give us x squared equals 3 times x plus 6. And then let's just do another step. Let's bring all of this over onto the other side, and I'm going to take away the brackets at the same time. So I'm going to have x squared, take away 3x, take away 18, which is 3 times 6, equals 0. So straight away you should be thinking to yourself, right, this is a quadratic equation, so I'm going to probably have 2 solutions for x. So let's first of all see whether we can factorise this. So the first term is an x squared, so each bracket will have x at the front. I'm going to look at this and I'm going to say to myself, well, I'm going to have, these signs have got to be opposite, because this times this is going to give me minus 18. And this minus 3 coefficient here means that the biggest factor I'm going to choose of 18 is going to be the minus 1. So my guess that we're probably going to use 6 and 3, because that's got a difference of 3. So minus 6 and plus 3. So there you go, we've got our values for x. So x is minus 3 or x equals 6. Okay, by saying that if 2 things multiplied together give 0, then one of these things, at least one of these things, has got to be 0. But let's look back at what we've got here. We've been told up here that all terms are positive. Remember, they told us that. Well, x is a term here, which means we can't have this. This isn't a solution, okay? That's not a solution. So all possible values of x means that this is the only possible solution. Okay, so we know what x is. And if we now just write in, so so part B is just to find the 10th term, okay? So let's see what we've got. We've got x, so let's just look at what our sequence looks like. So we've got 3, 6, and then we've got x plus 6 here, which will be 12. So that's what they've given us. So we can now see that what we're actually doing is we're doubling each time. So we now have everything we need to say that un equals, well, let's just write this down, to the n minus 1 equals first term 3, the difference is 2, 2 to the n minus 1. So all we have to do is plug in n equals 10. So u10 equals 3 times 2 to the 9. And 2 to the 9 is 512. So if you just pop that in, we get 1, 5, 3, 6. Okay, so those are the sorts of questions you're going to get. Something else you might be asked is simply, is a certain value in a certain sequence? Okay, so let's just pretend they've asked us this. So let's just pick a number out of the air. Let's say, is 36 in the sequence, okay? But all you have to do for that is say, if it is, so we want a value of n, so is there an n? And n here, we're assuming is in the natural numbers, which looks like that. So there are counting numbers, okay? So is there a value of n such that 36 is un, 36 equals 3 times 2 to the n minus 1. Okay, so in this case we've got to say, so that would be 12 equals 2 to the n minus 1. So in this case we can see that 12 isn't a power of 2, right? So there isn't a whole number of n for which this is true. So the answer is no. So that's the sort of thing you'd have to do if you're asked, is a number in the sequence? Find out, is there a natural number n such that you can plug it into the formula and get the value you're looking for. Right, actually I think given there are some quite nice questions in here in your textbook, it'd be worth you just stopping there. You've revised this and you can go ahead and do some other questions in your textbook. In fact, let me just write them down here. So change of plan, because I don't think you've taken this textbook home yet. This is a year 2 one, so I will give you examples. I'll send you a sheet of questions with the answers on a worksheet. Okay. Okay, so there you go. Have fun. Try some of the harder questions and see how you get on. But this should just all be revision, but it's going to bring in some other stuff for you, slightly harder questions than you would have seen at GCSE. So there you go. Have fun, and I'll see you next week.